NCERT solutions for class 9 math. We are in chapter number 13, surface areas and volumes, exercise 13.1, question 7, looking at total surface area of rectangular cuboids. Shanti Sweets Stall was placing an order for making cardboard boxes for packing their sweets. Two sizes of boxes were required. The bigger of dimensions 25 centimeters by 20 centimeters by 5 centimeters, and the smaller of dimension 15 centimeters by 12 centimeters by 5 centimeters. For all the overlaps, 5% of the total surface area is required extra. So we need to keep this in mind while computing the area of the cardboard required. The cost of the cardboard is rupees 4 per 1000 centimeter square. It's not per centimeter square, it's for 1000 centimeter square. Find the cost of cardboard required for supplying 250 boxes of each kind. Step 1. Let's compute the total surface area for both the sizes of boxes. For the bigger box, the dimension is 25 centimeters by 20 by 5. Total surface area of a rectangular cuboid, the formula is equal to 2 times of LB plus LH plus BH. Let's just plug in the values. This is going to be equal to 2 times of 25 times 20, 25 into 20, plus 25 into 5, which is L into H, plus B into H, which is equal to 20 into 5. Complete this calculation. 2 times of 25 into 20 is a 500, 25 into 5 is a 125, 20 into 5 is a 100. So this is equal to 2 times of 500 plus 125, 625 plus 100, 725. 2 times 725, this is equal to 1450 centimeter square. So total surface area of one big box is this. Let's repeat the exercise for the smaller box. Smaller box dimensions are 15 centimeters by 12 centimeters by 5 centimeters. Total surface area, the same formula holds good. Let's just plug in the values. 2 times of 15 times 12, L into B. L into H is 15 times 5 plus B into H, which is equal to 12 times 5. So this is equal to 2 times of 15 into 12 is a 180 plus 75 plus 60 is what we have. So this is equal to 2 times of 180 plus 75, 255 plus 60, which is 315. So the total surface area of a smaller box is equal to 630 centimeter square. So found out the total surface area of the larger and the smaller box. Quickly summarize this in a printed form. Area of the larger box, cardboard required, is the total surface area of the large cuboid, which is having dimensions 25 by 20 by 5. The area is given by this formula. Substitute the value. Answer is equal to 1450 centimeter square. Running through the same exercise for the smaller box, dimensions are 15 centimeters by 12 centimeters by 5 centimeters. Plugging it into the same formula to get the answer, which is 630 centimeter square. Let's compute the area of the overlaps required at 5% for the larger box and the smaller box. Larger box, we computed the area to be 1450. So 5% of that is required as overlap area. So that's 5 by 100 into 1450 should give us the answer. 5 gets cancelled with 100 to leave us with a 20. So this is equal to 1450 divided by 20, which is 72.5 centimeter square. So overlap required for a larger box is 72.5 centimeter square. The smaller box, running through the same exercise, area is 630. So 5% of 630, 5 by 100 times 630 should give us the answer. 5 gets cancelled with 100 to leave us with a 20. So calculation essentially boils down to 630 upon 20, which is equal to 31.5 centimeter square. So got the overlap for the larger box, overlap for the smaller box, 5% extra area. We'll quickly run through this overlap calculation in a printed form. For the larger box, 5% of 1450, calculation leads us to 72.5. For the smaller box, it's 31.5 centimeter square. The last step, we'll compute the total cost of cardboard required. Let's find out the cost of cardboard required for 250 such boxes. Let's start by computing the area of cardboard required for 250 such boxes. What are all the areas that we'll have to take into consideration? For 250 box, let's start with 250 times. That's a good starting place. Total surface area of a larger box, which is 1450, plus the overlap area at 5%, which is 72.5, plus the total surface area of the smaller box, which is equal to 630, plus the overlap area at 5%, which is going to be equal to 31.5. Let's add all of these things. Let's keep this 250 into, do this calculation in the last step. Don't do any intermediate calculations of multiplication. Addition is 1450 plus 630, that is a 2080. I'm just writing that bit here. I've counted this and this. Left to count 72.5 plus 31.5, that is equal to a 104. So all of these add up to 2184. So the area required for 250 smaller and 250 larger boxes after including the overlaps is 250 into 2184 centimeter square. All that is left is to multiply it with the cost. cost is rupees 4, not per square centimeter, per 1000 square centimeters. So we require cardboard of 250 into 2184 centimeter square. The cost per centimeter therefore will work out to 4 by 1000 because 4 rupees is the cost for 1000 centimeter square. So for 1 centimeter square, it's going to be 4 upon 1000. Total centimeter square is required are 250 into 2184. Keeping the calculation to the end has this benefit. 250 into 4 is 1000 that gets cancelled with this to give us an answer which is equal to 2184. Otherwise, if we had done the calculation at this stage, we would have computed the centimeter square area in a large number and would have tried to divide it, multiply it again with a 4. All that complications can be avoided. Quickly summarize it in a printed form. Area required for 250 boxes is the total surface area of the larger box. This is the total surface area of the smaller box. Overlap for the larger box, overlap for the smaller box. All these numbers add up to a 2184. So total area required for 250 boxes is 2184 into 250. At the rate of 4 per 1000 square centimeters works out to 2184 rupees. Before you leave, do a couple of things. 1. Sign up for online coaching for NCERT Class 9 Math at online.maxtube.com. Takes 3 steps and a maximum of 5 minutes to get you started. And sign up, subscribe to this channel, youtube.com/maxtube, and spread the word about this channel to your classmates and friends.